Hello, welcome back. We're going to continue working with square roots, but this time we're going to jump more back into algebra and have variables. You see a lot of books and a lot of tutorials out there jump you right into square roots with this material right here, and people get lost really fast because they don't understand how to break a square root into a factor tree, and so they don't understand the background. So when I give you a problem like 121 times a squared, and I want you to take the square root of that, you have no idea what to do because you haven't had any practice with it. But now we have. So I want you to look at this, and even though it looks a lot more complicated because this a squared is in there, what you really need to realize is the same rules apply, the same technique applies. The 121 is multiplied by a squared, and a squared is really a times a. Right? So all this stuff is under here, and ultimately what we're going to do is write a big factor tree to handle it. So let's first tackle the number part, right? What is 121? What times what will give you 121? Well, that's going to be 11 times 11, right? And then you have to ask yourself, what times what gives you a squared? So you see everything's multiplied here, so ultimately the a squared is going to be a times a. So now you look for pairs, right? Because you can't break 11 into anything simpler because it's already prime, and you can't break a or the other a down into anything simpler because it would just be 1 times a. So you can kind of think of this as simple as you can go in the variables. So now you look for pairs. I see a pair of 11s, and I see a pair of a's. So you treat it exactly as we've done all the other problems. When you see a pair, you can pull out a single item. So in this case, pull out a single 11. And we have a pair of a's, so we can pull out a single item, in this case a single a. The answer is 11a. Now you see how easy it is? If we didn't do all of that work in the past with just handling the radicals with numbers, you would be very lost with how to handle this. But now you just need to view everything under here as everything under here is all multiplied together. You have to write a giant factor tree for all of it, and then you can get the answers. All right, let's do the next one. You'll quickly see the pattern here, and they're actually kind of fun to do after a while too. 28 times x squared. And when I say fun, I mean, I know not all of us love to do algebra as much as I do, right? So when I say fun, I mean, about as much fun as you can have doing algebra. But after a while, the process becomes so familiar that it's not a big deal, I guess is what I'm trying to tell you. So here you have a big factor tree. All of this stuff is multiplied together. So we'll handle the numbers first. So what I like to do is kind of break this off and say, well, over here, the 28 is going to be something times something. We'll call it 7 times 4. I can't do anything with the 7 because it's already as simple as it can go, but the 4 can be 2 times 2. And now all of the numbers are in their simplest form. Now all of this stuff, see this, I kind of put the point of it right here, but really that's because I'm trying to show